Alright, welcome to my Module 3 lab video that's going to be performed on our lovely 1999 Acura 3.2 TL. Kind of looks like this one here, except it's got a little more faded paint. It's got the 3.2 liter V6, and so let's get into checking temperature sensors first.
Also, this Acura has a vacuum leak, and you can see there's no manifold, there's no mass airflow sensor. It is a speed density system, so you can see map value here, 4.35. Obviously the throttle position's messed up, but it's idling at 1400 RPM at 4.2, 4.3 nap. And the vacuum leak is right here off of that end cover, so you might be able to hear it. So watch out for that pulley leak. And it idles down while the fans are on. It idles down when you cover it up. So if I put this little piece of paper over it, I can come show you. The map has gone down. That's still messed up. And the idle's gone down too. It's down to 1200, 1100, so that's definitely something we need to fix. Here's the wiring for the intake air temperature sensor. You can see the red wire goes to your power, and the green wire goes to this sensor ground. Here's the AUT sensor in a vise. Right now it's at 2200 ohms. If I hit it with this heat gun, it drops right away. Down to 200 ohms. And then you take it off. And it'll start to come back up. I've got the data pulled up for the intake air temperature sensor. You can see right now it's at 85 degrees. The engine's warmed up. If I disconnect it, it raises the idle just a little bit, and it stops sending data as well. So you can see it says lower limit. It just says limit. It doesn't even go to a default value or anything. And if I hook it back up, the idle smooths out, and it starts sending data. Here's the wiring for the coolant temperature sensor. This red wire is the power wire. It gets its power from this junction, and then the green wire goes to the sensor ground. Right now I'm back probed into the ECT sensor. There's no spec in all data for the voltage or resistance of the sensor, but you can see it's at 3.1 volts with the engine coolant at 68 degrees. With the engine running, you can see that there's the voltage to the ECT sensor is dropping as the temperature increases. With the engine temperature warmer, you can see the voltage is dropping much more slowly. It's up to 136 now. It's now up to 165 degrees. If I disconnect the coolant temperature sensor, starts idling poorly, and you can see on the ECT sensor it's showing just says limit, but the idle definitely gets worse. When you plug it back in, it makes it better. So for this ECT sensor, you can tell it's a single range because right now it's at 0.5 volts. The voltage was dropped as it warmed up because the resistance increased. There was no jump back up to a high voltage, and then a descent to a lower voltage. It constantly decreased from about 3 down to this 0.5 that it's at now. It's at 203 degrees right now. In this vehicle here, it's a Corolla. You can see the accelerator pedal position sensor. It's under the dash on the driver's side. Your black wires here are your power for each side of the sensor. They have 5 volts. Your yellows are ground, and then green and white are the signal wires for each sensor. Here I'm underneath the car. I've got the throttle position sensor disconnected, and I've tapped into the ground to signal wire pin. As you can see, there's a resistance reading here, but on the scan tool there is no reading. So you can watch in the background as I push the accelerator pedal. You can see the resistance change on the meter. It's decreasing because that's the side of the, starts out at 2800 ohms and it decreases down to 900 because that's the side of the sensor I have tapped into. So in the Corolla here, you can see I'm pinned into accelerator pedal position sensor number 1 circuit between the signal and ground. That's pinned to my meter. Obviously, there's 2 sensors for redundancy, and then I also have absolute throttle position pulled up as well. You can see that here it's showing sensor 1 is at 0.77 volts. On the scanner it's the same. It increases as I hit the gas, decreases when I let off the gas. This other sensor is staggered to it. They're staggered apart by a little less than a volt, so they increase together but not to the same amount. So I'll pull up a graph for this here so you can see. I'll kind of set these next to you and do a sweep here for you. You'll watch the voltage increase. Should match the meters reading pretty well. We're looking for a nice predictable curve, no sudden spikes or drops. I'm being real smooth with it, as smooth as I can be. And that's pretty good, something like that we're looking for. There's no sharp spikes or sharp drop-offs at all. It comes back, it goes up smoothly and down smoothly again to the same voltage. Here under the hood of the Acura, I've located the TPS sensor. It's right here on the throttle body, and I have pins in. So this green pin is your ground, signal ground. This is your 5-volt reference, the yellow pin, and the red pin is your signal out. So I have a meter hooked up. I also have an Actron hooked up. I'll talk about that in a second. If we hook up to the 5-volt reference, we should have 5 volts. And we do. Now, if you hook up to the signal out to ground, should be low voltage because it's at idle. It is not. It is at 5 volts. As you can see here, the throttle is wide open at idle. And this is, well, the throttle position sensor is backwards. It thinks it's wide open right now. I mean, this is with a closed throttle. 4 volts, 90%. I'm gonna do a throttle position sensor sweep. So here's the throttle position sensor and the connectors that come off it. These wire colors are wrong, but these pins are colored to the correct wire. So green is your signal ground, yellow is your signal positive, the pin, and red is your, or this is your, I'm sorry, reference voltage, and this is your signal voltage. So you can see on my meter, it's got 4.47 volts with a closed throttle. So this sensor is working backwards. If you look on the Actron here, this bottom number, absolute TPS, is 90% at idle. So I will go ahead and do a sweep. I have this wrench here hooked up to the throttle. So as I move this, I'm gonna do it really slowly. All the way to 8 volts. We'll go back.
right back to 4.5 volts.